On to problem number 2 of the MIT Integration B Qualifying Exam 2012, which is the indefinite integral of x to the power 1 over 4, and others the fourth root times the natural logarithm of x. So an interesting problem, but let's see how we'll be able to solve this. That we're looking at is the integral of x to the power 1 over 4 natural logarithm of x dx. And as always, you look at the complicated expression or function and then try to substitute for it. So I like using u, so I'll just say let u be equal to x to the power quarter. And that means that u to the power 4 is equivalent to x, and so 4u to the power 3 du dx is equals to 1. And so we can substitute with 4u to the power 3 du for dx, right? So this is an important part there. And so now we have our integral now becoming, in place of this part here, we have u, right? And then in place of x here, we have u to the power 4 dx. This part here, we have 4u cubed du. And that means that now we do have 4u to the power 4, because we are combining this and that, natural logarithm of u for du. So an important thing in the rules of logarithm, if you have log of a to the power b, this is the same as b natural logarithm of a, right? So we're going to use that. So essentially we have, if we pull 4 out, we have u to the power 4, and then we're pulling this 4 out times 4 log u. And so this 4 and this 4 can now come together, and this is what we'll get. Eventually now we do have our integral being 16 u to the power 4 natural logarithm of u du. Next thing we're going to do is we're going to use integration by parts, and I'm using this rectangle here to circle an important expression. So if you have an integral of a function that consists of a product of one function u and the derivative of another function v, that's the same as uv minus this v here as the original function times the derivative of du. So this is an important part. In this scenario here, what we can say is that u is our dv, it's a derivative. So in a way we can represent it as 1 over 5, the derivative with respect to u of u to the 5, right? Log u. And so this is dv, and this here is u. So since now we're going to look at what is on the right hand side, uv is going to be, since our v is 1 over 5 u to the power 5, and then u is log u, so this is capital U, not small u, minus our v, 1/5 of u to the power 5 du, the derivative of log u is going to be 1 over u, right? 16 1 over 5th u to the 5 natural logarithm of u minus a fifth the integral of u to the power 4. All right. So it becomes really tractable here. Let's see how we can proceed with this. Our integral that we saw was 16, 1 over 5, u to the power 5, natural logarithm of u minus a fifth, the integral of u to the power 4. Yeah, that's what we have. It's the same as 16 over 5 u log of u minus 16 over 5 u to the power 5 over 5 integration constant, which is 16 over 5 u log u minus 16 over 25 u to the power 5 plus c. But since we said u is equals to x over 4, x to the power 1 over 4, the integral of x, natural logarithm of x dx, is equals to 16 over 5 x to the power 1 over 4 natural logarithm of x power 4 minus 16 over 25 x to the power 1 over 4 plus c. Since we said our integral of x to the power 1 over 4 natural logarithm of x dx is equals to 16 over 5 x to the power 1 over 4 natural logarithm of x to the power 1 over 4 minus 16 over 25 x to the power 1 over 4 plus c. We can again use this expression of logarithm when we said a to the power b is equals log of a to the power b is b log of a, right? So this integral is the same as pulling the quarter out, 16 divided by 4, 16 times a quarter, it becomes a quarter, it becomes 4, which is now 4 over 5 to the power quarter logarithm of x minus 16 over 25 x to the power 1 over 4 plus c. And that is, my friends, the final answer.